Now that we've introduced the idea of a type 1 region versus a type 2 region, now we get to talk about how to actually evaluate a double integral over that general region. So suppose that you have that z is equal to some function of x and y, and D is a general region in the xy plane. We're going to break this into two categories. If D is type 1, that means that D can be expressed in the following fashion. Y is bounded between two functions of x, and x is bounded between two constants. Then the double integral over the region D must be done in the following order. When we were going over rectangles, whether we did dy dx or dx dy didn't particularly matter. Here it does matter. It must be that when you're setting up your double integrals, that the constants come last. So a to b, that's going to be the integral with respect to x. Like we experienced in one of our example problems, it is actually okay to perform an iterated integral with variables as your bounds. We're now going to observe that to be the case for these type 1 regions. Now, to reiterate, the first integral that you're doing is going to be with respect to y. This is associated with this. And the second integral is going to be with respect to x. This is associated with this. So, x goes from a to b, and y goes from function to function. This is how you would set up your iterated integral to actually evaluate and then interpret as a volume. Now, in the event that D is type 2, we'll say that x is bounded between two functions of y. We'll call them h1 of y and h2 of y. And then y is bounded between two constants. Now, once again, order is going to be very important here. The double integral over the region D of f of xy dA will be equal to, once again, constants come last. Constants go last. Then functions of y can go first. The f of xy will stay the same. Now, we've gone with respect to x first, so x will go here, and we perform that iterated integral with respect to x. Then y comes last. That iterated integral, or definite integral at that point, will be with respect to y. Both of these represent the volume that's contained below the surface, z equals f of xy, within the given type 1 or type 2 region, D. In our next video, we'll talk about how to set up and evaluate one of these double integrals.